Shall we begin?
Hello, welcome to Bam Bam. Today's physics topic is kinematics using projectile motion. We will be learning about things moving through the air, like, for example, a ball thrown, a golf ball putted, or a ball kicked, footballs kicked, and even bullets. These happen in two dimensions, meaning in y and x axis. In projectile motion, air resistance is ignored because these are perfect world problems. We only take gravity into consideration when doing projectile motions. Gravity equals G negative 9.8 meters per second squared. Okay, projectile motion can be analyzed by using horizontal and vertical components separately, also assuming motion starts at t equals 0. T equals 0 means time equals 0. Alright, here I have a graph explaining the parts of projectile motion graphs. So here's your initial velocity in the y direction, which is vy naught. Here's your initial velocity in the x direction, which is vx naught. And this is your angle of degree, which is theta. And then here's your maximum velocity, which is v top. And this is the general shape of projection for the object. Okay. There are two general equations for projectile motion, one in the y and one in the x. Equation 1 looks like this. Y equals y naught plus vy naught plus 1/2 ay t squared. Okay, and this means the acceleration in the y. This is time squared. This is, as you know, velocity in the y direction, initial velocity in the y direction. And then displacement. This is for the y. This is equation 1. We also have another equation, equation 2, which is in the x. X equals vx naught times t plus 1/2 ax, acceleration in the x, times t squared. Okay. Okay, now using these equations, we could apply it to an actual problem. Okay. Alright, problem 1. Moving stunt driver on a motorcycle speeds horizontally off of a 50-meter high cliff. How fast must the motorcycle leave the ground level below 90 meters from the base of the cliff where the cameras are? Ignore air resistance. Okay. So in order to do this, we have to draw a graph. Okay, so here's the car, and this is the projection of its fall. The cliff is 50 meters high, and the ground is 90 meters long. Okay, so we have to describe our known and our unknown. So our knowns are known is x naught, which equals y naught, which equals 0. Our other known is x equals 90 meters. Our y equals negative 50 meters because it's falling down. So it has to be negative. Our acceleration in the x is 0, and our acceleration in the y is g, which equals negative 9.8 meters per second squared. We also know our vy naught, which equals 0, and our in the x. In order to solve out this problem, we have to work it out using these equations. Alright, so equation 1, y equals y naught plus vy naught times t plus 1/2 acceleration in the y times t squared, which then equals 0 plus 0 plus 1/2 negative g t squared. Since we don't have any of these, we can just cross them out. So then t equals 2y negative g, because you have to basically start from here. Then 2 times negative 50 divided by negative 9.8 equals 3.19 seconds, and that's your t. And that's part 1. For part 2, we're going to use the x equation, which is equation 2. X equals x naught plus vx naught times t plus 1/2 acceleration in the x times t squared, which then equals to 0 plus vx naught t plus 0, because these cancel out, which is vx naught x divided by t, which then equals 90 meters divided by 3.19 seconds, which equals 28.2 meters per second. And there you go.